Good evening, all. So we shall discuss the MCQ question on special function, right? In the previous lecture, we have seen some of the important question. Continuing that, we shall discuss few more in the same topic. So it is given j half of x is equal to root 2 by pi x sin x. This is the value of the Bessel's function, right? And j minus half of x, that is also given, that we know as a standard formula, that this is root 2 by pi x of cos x, right? So here we are asked to find out the value of j minus 3 by 2 of x, right? J minus 3 by 2 of x is required. Various options are given. Okay, so how do we find this value? So remember, whenever few values are given and you have to find out the new value for a basis function. So in that case, the thing which is useful is not the definition, right? The useful thing will be a recurrence relation. So here we will make use of recurrence relation. Why? Because here I know the two different basis functions of various order, right? Half and minus half. So this I am going to use. So first of all, you have to decide which basis function gives you this value, because as we have seen, there are total 6 recurrence relation, right? There are 6 recurrence relation. So which one we should use? So looking at the requirement, as we have two different basis functions of various order, right? So here we will make use of Bessel's recurrence relation number 6, because recurrence relation 6 says that here we have jn of x, jn minus 1 of x, and jn plus 1 of x. So three different Bessel's functions are here, right? Here we don't want the derivative, neither the two terms in the recurrence relations are same, right? So we will use the sixth recurrence relation. So that is given by 2n by x, jn of x is equal to jn minus 1 of x plus jn plus 1 of x. As we want what, the minus 3 by 2. So if you compare j half of x minus half of x and minus 3 by 2, right? So you will find that out of these three, what we will have, we have the what, the highest of them is half, right? So we will put n is equal to half, right? So if I put n is equal to half, what we will find, it is 2 into 1 by 2 is 1 by x, j half of x is equal to j minus 1 half of x plus j 3 by 2 of x. Okay, now simplifying it further, so what we get, so j 3 by 2 of x is equal to half of the value of j half of x is required, which is given, as well as j minus half of x is required. So we will put the corresponding values, and in this way we will get the value of j 3 by 2 of x, right? So this is nothing but the option number, what you can see here, that is nothing but option number A, right? So here it is, there is a change. What it is, the change is here we want the value of j 3 by 2 of x, right? So in this recurrence relation, you have to look for the highest augment term. What is the highest power term out of n minus 1, n, n plus 1? So this is the highest augmented term, right? Highest order term. So here I will make this n plus 1 as 3 by 2. So when this will be equal to 3 by 2 for n equal to half. This is the reason why I have substituted n as half in this example, right? Okay, now let's have the next one. The value of Pn of 1 is required, right? So again, this is the one of the formula that Pn of 1 is 1, right? Here I have mentioned that Pn of 1 is 1, but I would like to derive this, right? I would like to show you how we get Pn of 1 as 1. So this value of this Legendre function, right? Value of the Legendre function is obtained either by making use of the generating function or by making use of Rodriguez formula. Rodriguez formula gives you the basis functions of various order, right? That is P0 of x, P1 of x, P2 of x, like this. right? So the variable x will remain as it is. Whereas, what is the use of generating function? Generating function gives you the value of that Bessel's function for different values of x, right? That is, here it is what it is required. Pn at x is equal to 1 is required. Okay, so we will make use of generating function. So I hope this selection of generating function and the Rodriguez formula for getting the certain for values of the generating function is clear to you all. So let me repeat it again, right? If I want the value of the Legendre function, right? Legendre polynomial for different values of n, that is n equal to 0, 1, 2, 3, which we say generally as the Legendre polynomial of various order. Of order 0, of order 0 is denoted by p0 of x, of order 1 is p1 of x, p2 of x, like this, right? In that case, we will use Rodriguez formula. But if I want the value of Legendre polynomial, okay, for certain values of x, in that case we will make use of the generating function. Okay, so let's start here. So we will start with the generating function, because here I want value of Legendre polynomial for x is equal to 1. So the generating function is given by this 1 minus 2xh plus x square to the power minus half is equal to summation of h to the power n into Pn of x. Now, as I want the value of Pn of 1, right? So what we do, we will put x is equal to 1 on both the side. So when we put x is equal to 1, what we get? So here it is 1 minus 2h, x is 1, plus h square to the power minus half is equal to this one. Now if you look at this term, so you can find here that this term, right, this I can write as what? This is exactly same as 1 minus h whole square, right? This can be written as 1 minus h whole square, and then what I have, the power minus half. So this 2 will get cancelled according to law of indices. So I am left with 1 minus h raised to power minus 1, right? So this can be written like this, is equal to summation h raised to n Pn of 1. Now, as summation is there, right? So we can have, when we apply n equal to 0 and so on, we will get the various values. Now, so here we will apply the formula by binomial expansion. Which formula? As we know that 1 minus r raised to power minus 1, according to binomial expansion, is 1 plus r square and so on. Okay, so that we will apply over here. R is nothing but h. So we get this term equating both the side. So if you want, we can write it as, how we can write this as, so if you compare the coefficient of h to the power n, what is the coefficient of h to the power n over here? On the left hand side it is 1, whereas here what you find, the coefficient of h to the power n is Pn of 1, right? So therefore equating both the side, the coefficient of h to the power n, we get Pn of 1 is equal to 1. So in this way we get the formula for this, right? So this should be remembered as a formula, right? And if you are interested in the derivation part, so just now I have told you the derivation. Okay, now so next one, the value of Pn dash of 1 is, so here the value of Pn dash of 1 is required. So as we know that the Pn of x is a what is, it is nothing but the solution. This is a Legendre polynomial, which is a solution of Legendre equation. Okay, solution of Legendre equation. So what is the Legendre equation? This one is Legendre equation. Now what do we mean by solution? Solution means if I put in place of y, this will get satisfied and I will get 0, right? So in place of y, what I will write? I will write Pn of x. So this y double dash will now become Pn double dash, isn't it? This y dash will become Pn dash and y will get replaced by Pn of x. This is what we mean by a solution of the equation, okay, in general. Now, as I want Pn dash of 1, here you can find I am having first derivative term Pn dash of x, and as the requirement is of Pn dash of 1. So put x is equal to 1 here, right? So now what we get, when I put x as 1, so this is 1 square, which is 1, 1 minus 1, 0. So we don't want require the value of p the n double dash of 1. Okay, this will ultimately reduce to 0. Now, so what we have, minus 2, x is 1, pn dash of 1 plus n into n plus 1, pn of 1 equal to 0. Now, as I am interested in pn dash of 1, so we will obtain the expression for pn dash of 1. What we get? We get it as n into n plus 1, pn of 1. Just now, we have seen that pn of 1 is what? 1, right? So that I will put over here. So 1, and this is divided by 2. So what is the value of pn dash of 1? It is n into n plus 1 by 2. Hence, the correct option or the answer for this example is option number A. Now let's have next important question. Which of the following is true? So this is what we require here, right? So here various formulas for Legendre polynomial is written. So let's see which one of them comes out to be true. So again, as the Legendre polynomial for various values of x is required, you can see here, right? Pn of 1, Pn of minus 1, Pn dash of minus 1, right? Pn dash of 1. So in this case, what we will use? We will use the concept of generating function. So let's use concept of generating function. Now as I want minus 1, Pn of minus 1. So let's put x is equal to minus 1 in equation 1. So what we get? So when I put x as minus 1, this will become 1 plus 2h plus h square to the power minus half is equal to, simplifying and collect. Then again comparing coefficient of h to the power n on both the side, which we have done earlier. What you will find? You will find that the okay. So you will find that Pn of minus 1 is minus 1 raised to power n. Right. Now again minus 1 raised to power n. So this can be written as what? I can write it as like this. Pn of minus 1 is minus 1 raised to power n, which in turn can be written as into 1. And just now we have seen that minus 1 raised to n and 1 can be written as Pn of 1. So in this way, I will have the relation. What is that? Pn of minus 1 is minus 1 raised to n Pn of 1. So let's see which of the earlier options were true. So in none of the cases, I am getting the correct choice. Pn of 1 is 1 as we know, right? Then just now we have seen Pn of minus 1 is minus 1 raised to n, and this is totally wrong. So only correct option is option number C. Okay. Now let's have next one. So as we have discussed in the previous lecture that we have a orthogonality property for a Legendre function. What is the orthogonality property for a Legendre function? So it says that the integral from minus 1 to 1 of Pm of x into Pn of x is 0. When it is 0, when both are of different order, right? M and n are different. And when both are same, then we have 2 upon 2n plus 1. Now, if you look at the options given over here, right? If you look at the options given over here, you may say that sometimes you may get confused that 0 is here. So this is also correct. And 2 upon 2n plus 1 is there. So this is also correct. So look at the condition given. 0 if what? M is not equal to n. So this is not correct. Okay. This is not possible. So only option is this one, right? So you have to be very cautious while selecting the options, right? Correct options. So this is C, option C here. Okay. Next question, which of the following is correct? P0 of x is equal to what we have 1, then 1 by P3 of x, P4 of x, all these values are required here. Right. How do we get this? So one option is either you remember these formulas, or what is the another option, or you should derive the formula, right? So according to me, if it this being a multiple choice question, so better is to remember the values, right? Remember the value of Legendre polynomial of various order, P0 of x, P1 of x, P2 of x. Okay, And as in my video lecture, I have told you how to obtain the Legendre polynomial of various order using Rodrich's formula. Okay, so let us see which of them are correct. So as we know that, yes. So we will start with P0 of x, right? If you don't know the expressions, you can note down these expression. So what is P0 of x? This is always 1, right? P0 of x is always 1. Then what we have next? We have next as P1 of x. Okay, P1 of x. What is P1 of x? P1 of x is x, right? P1 of x is x. Then what we have next one is P2 of x, right? We want P2 of x. What is P2 of x? So by Rodrich's formula, so what is P2 of x? So by Rodrich's formula, we get P2 of x as, so P2 of x is nothing but half of 3x square minus 1. Okay. Then we want next P3 of x. Let me write P3 of x also. So P3 of x is half of 5x cube minus 3x. Then we want P4 of x. So I will suggest you to at least remember the values up to P5. So it is P4 of x is 1 by 8, 35 x to the power 4 minus 30 x square plus 3. I will tell you some observation also, right, which will help you to identify sometimes the incorrect options. So P5x x is 63 x to the power 5 minus 70 x cube and plus 15x. Okay. Now, if you observe this here, so here when the order is n is 0, right? When n is 0, I am having a constant term. What is that? 1, right? Now, when we have n as 1, n ki value 1 hai, right? When we have n as 1, so there you will find the highest power of x over here is 1. So what we should get? X power 1. Okay. Now, P2 of x, power 2. So highest power term must be 2. Again, as this is 2, which is an even number, so you will find all the terms of x with the even power. So highest power must be 2. So what is the next term? That is x power 0. X power 0 means constant term would be there. Okay. Now P3. P3 is odd, right? This is odd. So you will find highest power term as x cube with certain coefficient obviously. But apart from this, you will find another term with the power odd. What is that? X power 1. Okay. Here we have power 4. So highest power 4, then 2, and then 0. Power 5. So highest power 5. 5 after 5, the next odd term is 3. After 3, we have power 1. Right? So in this way, sometimes the option itself you will help you just by making use of the simple logic to identify which of the following are the incorrect options, right? So see here, P0 of x only constant term. Yes, that you, I think this formula is easy to remember. P0 of x is 1. Okay. Now P3 of x, so power 3, yes, I am getting. So I just have to see their coefficients. Okay. So it is 5, 3, 1 by 2, correct one. P5 of x, power 5, 3, 1, all are there. And if you compare it, so we find the option is correct. Now P1 of x, as I said, 1. So here I should have power x as power of x as 1, so which I am not finding here. So obviously this is not the correct option. So this is out of the box, right? This is not possible that all the four options are correct. Now again, just now we have seen 1 and 2. Yes. So you just have to be cautious about third one, whether it is correct or not. So if you remember the formula, then you will be able to decide it. According to me, only 3 is also discarded, right? So you just have to choose from option number A and C, right? 1 and 2 or 1, 2 and 3 also. So the decision will be taken correct if you remember the value of P5. Okay. So here what is the correct option? So correct option is option number C, 1, 2 and 3. Okay. Okay. Now let's have next one. Pn of x is the coefficient of h to the power n. Just now we have seen many times what is Pn of x, which is coefficient of h to the power n, which is also called generating function for the Legendre polynomial, right? Or Legendre function. Okay, so how do we get this? So if even if you remember the formula now, sometimes you may get confused. So obviously looking at the option, this is completely wrong. Looking at the power 1 by 3. Now next you have to, again this will be discarded. Why? Because power is plus half, power is negative, so this is also discarded. Now you have to choose from these two, right? Whether both of them or only one, right? So obviously here this is not possible, but 1 plus h square is not possible. If I write it as 1 minus h to the power 2 and then minus half, then that would be correct. Okay, so this is also not uh, that would be correct provided value of x is 1. So this is also not possible. So only option left is this one, option number B. Okay, so you have to be very much cautious. ये h है, here it should be x square, right? Sometimes x and h will get mixed in the sense, you may find sometimes the option like this also, 1 minus 2xh plus say x square. In that case the question would be, it will not be h to the power n, the question would be, it will be x to the power n, right? So this is also possible. Okay, so option B is the correct one. Next one, which of the following is true? We know yesterday itself I have told you that we have two different relations for gain of minus gain of x. What is one? One when we have jn of x, right? So either you change x by minus x, right? Then also you will get minus 1 raised to n jn of x, or if you replace n by minus n, right, and leaving x as it is, then also you will get the same thing, minus 1 is to n jn of x, right? This formula, this trick will help you to identify which one is true. Yes, which one is true? So I think option number A, right? The others are not true. Next one, but it is given here a second order differential equation is given, right? Where P is P1 of x upon P0 of x and Q is P2 of x upon P0 of x. So when the roots of individual equations are distinct and not differ by an integer, say m1 and m2, then the general solution of differential equation is, right? So we have seen that when the roots are different and they not differ by integer, they does not differ by integer means what? It means if you will find the difference between these two, right? If you will find difference between these two, either you find m1 minus m2 or m2 minus m1, this will not be a integer. You know very well what is mean by integer. So if you are not getting that as an integer and both are different, then the general solution is nothing but given by option number A, that is A times value of y at m1 plus b times value of y at m2. In this way we get the solution. Okay, so different cases we have been discussed while dealing with this particular topic. So you have to remember those two those different cases, right? So clearly it's clear that here we everywhere we find a is multiplied with x, then x square, x cube. Obviously that is not the choice in any of the options, right? So answer A is the correct one. Yes, the value of P1 of x. Yes, this now I told you, by making use of the Rodriguez formula, you can get the value of P1 of x. And what is P1 of x? So obviously looking at the options, I have told you here the this order is 1, which is an odd one, right? So whatever will be the order of 1, that will be the power of x, highest power of x. So if you find here the order of x is 0, here it is x square, which is more than that, and 0 it's not possible, so only option left is x, right? So P1 of x is nothing but x. Okay, so this can be verified only by remembering the formula or by making use of the trick. So you should be lucky enough that if the choices will be given in that way. If choices will be confusing, then only thing which will help you to get the or to choose the correct option is by remembering the formula. Okay. Next question, what it is said, the complete solution is given by this one, a times y at m plus b times del y by del m at m, when the roots of individual equations. So obviously, undoubtedly we can choose the correct option, that is when the roots are equal, because you can see here the value of y as well as del y by del m both are evaluated at m, so the roots are equal is the only possibility. Now, which of the following is correct? Yes, so I think this is repeated. Now let's have the next question. D2y by dx square plus p dy by dx plus q, where these are the condition given. Now what it is given, x is equal to 0 is a singular point, right? X equal to 0 is a singular point means p 0 of x is 0 at x is equal to 0, right? This is what equal to sign is missing here. But x times p of x and x square times q of x are finite as x tends to 0, then x equal to 0 is. Yes, we know very well that if we have a singular point and if I multiply p by x and q by x square, and if we will get the finite value at that point, then that point is called as a regular singular point. Okay, this is according to definition of regular singular point. Condition required is it should be both the values must be finite. If either of them will be infinite, right, then it won't be a regular singular point. Let's have the next question on the same base. What it is, x to the power 4 d to the power d2y by dx square plus is 0 is given, then x equal to 0 is what we call, what is the nature of this, singular point, ordinary point, regular singular point, or not singular point. So let us check this. So first of all, we have to identify here the p0 of x. So p0 of x is coefficient of d2y by dx square, which I am getting as x to the power 4. Then p1 of x is coefficient of dy by dx, which is x square. Then we have p2 of x, which is 1, coefficient of y in this differential equation. Okay, now so we will define p of x. What is my p of x? P of x is p1 of x upon p0 of x, which is nothing but equal to what? Which is equal to p1 of x is x square, and then we have upon x to the power 4. So this comes out to be 1 by x square. Similarly, q of x we will find out. So what is q of x? So q of x is nothing but p2 of x upon p0 of x. So which is 1 upon x to the power 4. Now let's find out whether a point is a singular point or not. So p0 of 0, we will find out p0 of 0. So obviously p0 of 0 is 0. So this implies x equal to 0 is singular point. Now let's go for the advance in this. So we will find out capital P of 0. Capital P of 0 means value of this at x equal to 0. So what we get? We get this as infinity. Again q of 0 also comes out to be infinity. So both are not finite. So that's why what is the nature of this point x equal to 0? It's not a regular singular point, right? It's a singular one, but it is not a regular singular point, right? So option D you have to select. Okay. So I hope these set of problems you have you will find out useful to answer the questions on the MCQ type questions on the special function and series solutions. So thank you all for joining the class. We shall end